So in this example, I'm going to go through one example that utilizes both the AC method and the modified AC method. I want you to see both of them at work. Then after this example, I'm primarily going to stick with the modified AC method when factoring. I think it's a lot faster that way. But some of you may be familiar with the AC method, maybe more comfortable with it in the long run. And so I would allow you to use either one. However, like I said, the modified is going to be a lot faster, and so I'm going to stick with that personally for the rest of my videos as a general principle. So, but let's go ahead and work this out with the full AC method one time, and we'll see how you'll see how this plays out. So I got 15x squared minus 7x minus 2. Okay, and I've got that set up on both of these columns here, so I can do it in both methods. Again, you always start when the leading coefficient is not 1, you always start by calculating AC. Right? And in fact, I'm going to go ahead, because I need to do this for either case, I'm going to go ahead and put this kind of in the middle. So this would be the first step in both of these methods, okay? It's this AC. Now 15 times negative 2 is negative 30. And I then need factors of negative 30 that add up to negative 7. So I make my list of factors. If I don't see it right away, I make a list. And I go with 1 and 30, 2 and 15, 3 and 10. That should be all the factors, right? But I do need one of them to be negative, because I need a negative product. And the one I want negative is the bigger one, because the middle term is negative. So when I add them together, the negative needs to dominate. So we're going to use the negative on the bigger of the two numbers. And the combination that will give me negative 7 is the 3 with the negative 10. Okay? So that's a process, that first initial process right there is going to be true for both the AC method and the modified AC. That's why that's why they both have AC in their name, because you have to go through this process anyway, right? So I found that. Now the AC method itself, the full AC method, takes these two terms and replaces the middle term with them. Okay, so we'll do that. We'll take this middle term and we'll split it up into a 3x and a minus 10x. Actually, we'll call it plus 3x. So it's a plus 3x and a minus 10x. Then I bring down the first and last terms. So it's a 15x squared at the front and a minus 2 at the end. Okay. Now I have four terms, right? 15x squared plus 3x minus 10x minus 2. I'm going to then take the first two terms, group them together, take the second two terms, group them together, and then go through the whole grouping process to finish factoring this. So the first two terms have a common factor of 3x. And when I pull that out, I'm left with a 5x plus 1. Right? If I pull out the entire 3x, I have to have something left over, so it's going to be a 1 there. And you can always check that, because when you multiply back in, 3x times 5x is 5x squared, 15x squared, and 3x times 1 is 3x. Okay, so you can always multiply that back in to double check. The second set, I'm going to pull out a negative 2, and that's going to give me 5x plus 1. Okay, again, 5x plus 1. Notice it is the same in both terms, same binomial, so I can pull that common binomial factor out, 5x plus 1, and I'll be left with a 3x minus 2 as my other factor. Okay, so that's the full AC method. Again, it's not terrible. You do have to do basically this grouping process at the end. Actually, your textbook calls this grouping. It says you're factoring trinomials by grouping. Okay, so this textbook is a little bit different than others. I call it the AC method, and a lot of other books call it the AC method. Your textbook calls this grouping, though. Because really that's what you're doing here. From this step down, you're just doing the grouping method. Okay, so let's look at the modified AC. And you'll see, I think it's a little bit quicker, and maybe simpler. So again, you would start out doing this whole AC calculation, finding the factors that add up to -7, and we found there are 3 and -10. And so right away, once I do that, I set up my two sets of parentheses, and remember, I set in the two sets of parentheses, I put 15x. So my first term is 15x squared, so I'm going to do 15x for both first terms, okay? Then I'm going to put the 3 and the -10 in, I'm sorry, yeah, plus 3 and -10 in the parentheses with those 15x's. Then again, if I multiplied 15x and 15x, I get 225x, not 15x squared, I should say. So it's not going to work out. I've got to get rid of 15 total, a factor of 15 total. And so to do that, I'm going to divide out a common factor from each of these. Here there's a common factor of 3, and here there's a common factor of 5. Now it could be the case that you don't get a common factor in one of these sets of parentheses, and that's okay. You don't have to factor or divide something out if there isn't one there. You only have to divide common factors out if they exist. Okay. Once you've divided this out, the simplified fractions are going to be 5x plus 1, and here it's going to be 3x minus 2. Okay, again, the answers match up, so we did that correctly. So I think this one works a little bit faster, but again, you're free to use whichever method you want. For the rest of the examples, I'm going to focus in on using the modified AC method.